simplification, as I told you, it is like 3 types. First, we are going to see removing null productions. Okay, so removing null productions. So please try to pay attention for this, these 3 types. Okay, so many questions on context-free grammar, similar to DFA and NFA in grammar, like these 3 processes. There'll be a lot of questions on any objective test that you take, like GATE or any other UPSC exams. Okay, so removing null productions. So in eliminating null productions, we have 2 types of languages. So there are 2 types of languages. Epsilon is part of the language. Null symbol in some cases will be part of a language, and epsilon is not part of the language. That is, epsilon cannot be, how do I say epsilon is part of language and epsilon is not part of language? If epsilon is directly reachable, from the start symbol. So this is my start symbol. If epsilon is reachable directly, the empty epsilon, okay, only epsilon, not with combined with terminals and all. The standalone epsilon, if it is reachable from the start symbol, then we say this epsilon is part of the language. If I cannot reach epsilon from the start symbol, then I say that, then I conclude that, okay, this language doesn't have a epsilon. Epsilon is not part of the language. So epsilon is part of language. You've seen so many examples, even number of zeros. We constructed DFA for even number of zeros. So even number of zeros means 0 zeros, 2 zeros, 4 zeros, and so on. Okay, even number of zeros and even number of ones, if you have an even number of ones, both can be 0. So epsilon is part of the language also. Okay, so how do I check that? So I can check if epsilon is reachable from the start symbol. Given a grammar, how do I check that? Epsilon, the single epsilon, if it's directly reachable from the start symbol, then epsilon is part of the language, else epsilon is not part of the language. So we'll have to know that. We'll have to know how to check that. So that's the first step. Okay, so removing null production, the first step, we should know if epsilon is part of the language. If the epsilon is part of the language, I'll tell you, you should not forget to include the epsilon in the production rule of the start symbol. That is why we are checking this. Okay, we might eliminate epsilon from the other production rules, but make sure you have to include a single epsilon as a valid transition, valid production rule, as a valid beta. So, you know, alpha tends to beta is the format of production rule. So in a beta, epsilon should be present in the production rules of the start symbol. We should not forget this. So that is the purpose why I'm saying this. Okay, so why you should find if epsilon is part of the language or not. So that you have to find. And find direct null productions. This can be directly removed. So direct null productions. What are direct null productions of the format this t tends to epsilon? This is a null production. So left side there is a non-terminal or a variable, and right side there is epsilon. So this is like direct null production. So identify direct null productions. You can remove it. Okay, and then third thing, other terminals, other non-terminals. You have to check other non-terminals. Okay, so other non-terminals are variables. You're going to check if they are nullable. Check if they are nullable. Okay, so these 3 steps are checking. Okay, so I'm going to check all this and then I'm going to edit my grammar. Okay, to simplify the grammar, I'm going to edit it. So get the whole picture. We are trying to simplify our grammar. Okay, so the first way of simplifying is there are 3 steps. Some simplification, all 3 will be required. The grammar will be so so unclear that all 3 simplifications are required. That depends. So we have to check our grammar for all 3. Check for null productions, check for unit productions, check for useless symbols. So only when our grammar passes through all these 3 checking, it is simplified. Okay, so we have to do all these 3. So checking is done. Okay, then editing, what should I do? In editing, so first, when I have direct null production, remove beta parts that have, so remove beta parts that have direct null production, that have this direct null production symbols. Okay, so we'll see an example for this. So this is like if I have t tends to epsilon, epsilon we know it's a null production. Then if I have a tends to at and ab, I can remove this. T tends to epsilon is a direct null production. Okay, so I'm going to remove this direct null production. Okay, I'm going to remove this direct null production. T is not a start symbol. Remember, T is not a start symbol. S is my start symbol. Okay, S is going to be my start symbol. So when it's a non-start symbol, this is a direct null production. So I'll remove this direct null production. So wherever I see beta part with this non-terminal null production, I just try to remove that also. This is one edit. And the second edit, like I can have indirect nullable variables also. So these nullable non-terminals. So this is direct null production. This is the other type, nullable variables. For this nullable variables, I'm going to replace nullable variables incrementally and create the grammar. Variables incrementally. I'll replace nullable variables incrementally in the production rules, and I'm going to edit the grammar. Okay, so these are the 2 steps in editing. Okay, so these 2 steps are in editing and the first 3 are in checking. So this is how we simplify using removing null production. So let us see with 3 examples, okay, so that we better understand whatever we've talked in theory so far. So example 1. So let us take this grammar. If you have a notebook, please solve it along with me. That will help you understand better rather than watching. Okay, so this is going to be my first production rule. S is my start symbol, and this is going to be my second production rule. Okay, now I'm going to check if, what do I check? I'll check if epsilon is part of my language or not. Epsilon is part of my language or not. Yeah, how do I check? So directly there's no epsilon. So S tends to A tends to epsilon. But let us see. So what I'll do is I'll remove the direct null production. So for now, it seems like, so first I'll check like epsilon part of language. So let me do that. So what do I do? S tends to, so the only thing is that can lead me to epsilon is A, B. Fine. A tends to epsilon. Fine. But still it is AB. I don't get a single epsilon. Am I right? So epsilon is not part of language. So epsilon is not part of language. So in the final edited grammar, I need not include a epsilon. So this checking I've done. And the second checking, I'll go for what else do we have to check? So direct null productions do we have? Yes, we have direct null production. So what is a direct null production? So we have A tends to epsilon. I'm going to remove it. Okay. Sometimes we'll get it after multiple steps, but this is a direct null production. So I have to remove A tends to epsilon. So this has to be removed. Okay. And editing I'll come later. So I'll check if other terminals are nullable. Non-terminals or variables are nullable. I'm going to check other non-terminals. So A is nullable. We've already seen because it's a direct epsilon null production. Okay. Now we'll check S. Okay. We'll check if S is nullable. So S tends to A, S, B. This will not lead to epsilon at any chance. Okay. And A, B. Okay. So again, A, B also. Even if you substitute, it's going to give a terminal AB. Okay. And AB again, the third string AB, this AB1 has only terminals. So S is not nullable. Okay, so we have, and before all this, it is always easier if we write down all the terminals and non-terminals. Okay. So these are the terminal symbols, and non-terminal symbols are S and A. Okay, non-terminal symbols are S and A, terminal symbols are A and B. Okay, so S is not nullable. So now we are going to edit. So edit, I'm going to remove this A. This is my input grammar, remember. So this is the grammar. So here I'm going to cross out this directly. So epsilon is not part of language, and I'm going to cross out this. If I cross out the null production, I have to remove all beta part that has, so this will be removed. This I have to remove. All beta part that has this A has to be removed. So S tends to what do I do? S tends to ASB or AB. Okay, this I'll directly remove because it's a null production. Okay, so the simplified grammar is this. So we have simplified our grammar using null production. So this is the simplified grammar. Okay. Right. So this is our simplified grammar. So we are checking if epsilon is part of language or not. Let us keep it. And in case there is any direct null productions, remove it. Check if all the other non-terminals are nullable or not nullable. Okay, now it is in this case it is not nullable. We'll see next example. We'll see with nullable terminals. If S is nullable, what should we do? We'll see. So we have seen replace nullable variables incrementally in production rules. So this we have not yet done with this example. We'll see it in the next example. So from our grammar, we have got a simplified grammar using removing null production. Now let us see another example. So this is the grammar. S tends to AB, A tends to AAA or epsilon, B tends to B, B, B or epsilon. Okay. Now that empty string is, empty string is part of our language. Am I right? So empty string is what? It is part of our language. We can see S tends to A or B. If I substitute both can be substituted with epsilon, epsilon. So I can reach a single epsilon directly from S. That means epsilon is part of language. So we have to remember this while writing the final rule. Okay, fine. Now there's no direct, there are direct productions like A to epsilon, B to epsilon that we are going to remove. Okay, direct productions are A to epsilon, right? We have A to epsilon and B to epsilon that we are going to directly remove. Okay, we are going to directly remove it. But it is not only A doesn't tend to epsilon alone. Only in that case we'll be directly going and removing this. But I have other strings that can transit from A having terminals. So I cannot directly go and remove AB. Remember, in our previous case, okay, A tends to only epsilon. There were no other rules, no other production rules, no other beta possibilities. Okay, so that is why we directly removed this from our input, from our grammar in S. Okay, here I cannot do it because A has other combinations also. Capital A has other combinations also. If it has only epsilon, I can remove it. Okay, so here I cannot remove it. So I'll wait. And what is the third one? We'll check for other nullables. So we'll check if S is nullable. If the other things are nullable, we'll check. Okay. Now, what we'll do is we'll try to replace now. Okay, so S, A, B, all we have found that it can be, those are nullable, right? So in S from S I can reach epsilon, from A I can reach epsilon, from B also I can reach epsilon. So all are nullable for us. So what do? I'll try to edit my grammar. So how do I edit my grammar incrementally? When I see nullable variables, how do I do edit? I can say that S, A, B, all I have to edit. But how? We'll do that. Okay. So first step, we'll take S. S tends to AB. So you have to replace one by one. Okay. So I'll do it. So when you replace only A with epsilon, I get a B. Only B with epsilon, I get a A. Okay. Or I don't replace at all. So this is without replacement. Remember, you will have to write combinations without replacement of epsilon as it is I've written, and these two are with replacement. So this is what we meant by when we see nullable variables, do replace the nullable variables incrementally in production rules. So this is what I mean by incrementally. So without what is there existing as such, you write it AB. So without replacement, and try to replace one by one. So both A and B are nullable, right? So we have found that S, A, B all are nullable. So I'm going to replace A and B one by one. Okay, so this is the production that I finally got. S tends to B or A or AB. So this is what we've got for the first production rule. Now let us take the second production rule. Okay, capital A tends to AA. So we have removed epsilon. Fine. So without replacement, let me write first without replacement. So with replacement, let me replace one A with epsilon. Okay, the leftmost A. Then we replace the right A. Okay, one of the A's will be replaced with epsilon. Then let me replace both A's. Okay, so when you have like repetitions, try to remove the repetitions. So it's all the same like this. So we have simplified the second production rule. Now let us simplify the third production rule. Okay, so third production rule is B tends to be capital B, capital B. Now B is a nullable symbol. So how have I found it's nullable? So from S, A and B directly I can reach epsilon. Okay, so those are nullable. Now what do? I try to replace it. So B as such I'll write without replacement. Then with replacement, B and B alone, 3 times 1 B alone, replace both B's with epsilon. So I remove repetitions and write it like this. Okay, so let me write my simplified grammar. So when you write the simplified grammar for removing null productions, okay, so S tends to B or A or AB. Remember, I have to write a epsilon here. Why? I found that epsilon is the part of the language. So this is why we found this. Okay, so if epsilon is reachable from S with your raw grammar, if epsilon is reachable from S, please include that in the production rule of S. Okay, so then write the remaining production rule as we have simplified. AA or A and B tends to as such with replacement. It's A. Okay, so this is our simplified grammar. Okay, so we have followed all the rules and we have simplified. We have found the nullable variables. What are the nullable variables? Whichever variables that can lead you to epsilon. Okay, so those are nullable variables. Either they'll directly lead you to epsilon. Here A and B are directly leading to epsilon. S is indirectly leading you to. It helps you to generate epsilon. Directly or indirectly, whichever variables help you to generate epsilon are called nullable variables. So when you see nullable variables, S, A and B, all you found it to be nullable. So what you do, you'll change the production rules. You change the production rules with and without replacement. Okay, so without replacement, you'll write it as such, and with replacement, you'll replace incrementally one by one non-terminal that can be replaced with epsilon. You do it incrementally and keep generating the grammar. Okay, so this is an example of removing null production. And we'll see another example and we'll move to the next simplification. Okay. S tends to AB, AC. A tends to BC. Now B tends to B or epsilon. C tends to D or epsilon. D tends to D. Now, is epsilon part of this language or not? Can you check and tell? Epsilon is part of this language or not? The language generated by this grammar. This is a grammar. To check if epsilon is part of the language, you should check if epsilon can be generated directly from the start symbol. Is it part of the language or not?
Yes, ma'am.
Yes? Is it part of the language?
Yes, ma'am.
How do you say it's part of the language?
C, ma'am. C
okay,
can be
C, I replace it with epsilon. Okay, but still I have non-terminals in my string, right?
Oh, yeah, okay, ma'am.
Only
okay,
epsilon should be there. Okay, only epsilon. So I can never reach a single epsilon with this grammar because always it has non-terminals. I'm sorry, always it has terminals, terminating symbols. Okay, so always a single epsilon, reaching a single epsilon is not possible from my starting symbol. Okay, so I conclude that epsilon is not part of my language. Please do checking like this. Remember seeing the terminal symbols also. If I find any terminal symbols, I cannot generate a single epsilon. So epsilon is not part of my language. Okay. So now we'll write all the non-terminal sets. So non-terminal is S, A, B, C, and D. And my terminal set is A, B, and D. All right. So A, B, and D are my terminal sets, and S, A, B, C, D are my non-terminals. Now we'll check if the variables are nullable. Okay. So you can see B and C are directly nullable. Okay. So I'm going to create a set of nullable terminals, non-terminals, nullable variables. So I can see B and C are nullable because they directly correspond to null productions. B tends to epsilon, C tends to epsilon. So B and C I can include. So let me check the other variables. I'll check S first. So S tends to A, B, A, C. So whatever I do, what happens, as Arvindan said, like this will be retained. So whatever, even if I'm able to replace both with epsilon, still terminals remain. So S is not nullable. S is not nullable because it has terminals. Okay. Now BC is included. Let me check A. B and C is there. I can substitute epsilon for both. Right? I can substitute epsilon for both. So it is nullable. A is nullable. Okay, so S is not nullable. A is nullable. So add S. Add A. A is nullable. S is not nullable. Okay. And similarly, let us see D. D directly corresponds to a terminal symbol. So D is also not nullable. I write D is not nullable. So these are the nullable terminals. Okay, so direct productions, obviously I'll remove this B, this epsilon and this epsilon I'll remove. P tends to epsilon, this epsilon I'll remove. So what should I do with the other? I should consider all the rules to replace this nullable symbols incrementally. So that is the next step that I'm going to do. Okay, I'm going to replace all the non-terminal, nullable non-terminals incrementally in my production rule. Okay, so what I'll do with S, please remember, write the without replacement, write as such whatever you have. Now, what do you have in this set? A and B, both, A and C, both are in this set, right? Both the variables in this A and C, both are nullable, right? So replace them one by one. So first let me replace A, then let me replace C, then let me replace both. Okay. Now, should I write an epsilon here? Remember, you can write an epsilon here only when epsilon is part of the language. I've done this checking and I've decided it is not part of language. Okay. So this is the first thing I'll do. Then only I'll check for this nullable cases. Okay. So I cannot write an if epsilon is part of the language. Please remember, we would have removed epsilon from all other. So you have to write an epsilon here. Don't forget to do that. Okay, so for my first rule is done. Now let me take the next one. I'll write BC as such. And both B and C are there. Both B and C are there. Okay, so I'll write B. Then I'll replace and write C. Okay. Write epsilon only in the start symbol. If epsilon is a part of the language, write epsilon only at the start of the language. You need not write at other places. So that is eliminating null production. Okay. Only at the start symbol if epsilon is part of the language. Now let me go for B. B tends to B. I'll remove epsilon. C. C tends to D. I'll remove epsilon. D. D tends to D. Okay. So this is what is our final edited grammar. So we have simplified grammar for null production. So this is our simplified grammar. So as you see, just as you see the grammar, you can see a lot of ambiguity still in this grammar. Say C to D and D to D. There is no other work that C does. C goes to D. Yes, D directly goes to the terminal symbol D. By just seeing this grammar, I can tell directly, I can say C goes to small d, right? So all these things are what we'll remove in useless symbols. We'll find useless variables and we'll try to remove it. Okay. So as you can see, what is the conclusion is, I cannot stop with removing null production. Removing null production generates a lot of, removing null production at times will increase unit production in the grammar. Increases unit production in the grammar. So what is a unit production? Unit production is of the form non-terminal tends to non-terminal. This is unit production. This is the unit production. C tends to D. Non-terminal tends to non-terminal. That is a unit production. Okay, fine. So the next step is, okay, we have seen 3 examples to simplify the grammar by eliminating null productions. So next examples we are going to see is to eliminate unit production.